Welcome back to Hip Square. And as you can see, we all look so great in little white suits. And I'm so excited because today's experiment, we are blowing something up, aren't we, Erin?
At last, yes, we're setting something alight, and I'm not the one doing it. No, we decided that seeing as I'm just a mad scientist, it was time to get a super scientist on the show, and his name is Simon Broadley. Simon, welcome to the show.
How's it going?
Okay, so what are we going to be doing today?
We're going to be mixing acid and a metal to make hydrogen gas.
Okay.
We're using hydrochloric acid and aluminium foil.
Great stuff.
Cool.
So while you do that, hydrogen balloon, and I see this candle and matches. Makes me think Hindenberg balloons blowing up, setting a flame with hydrogen. Is that basically what we're going to be recreating?
That's what we're going to try and recreate, yeah.
Fantastic. So let's get our bottle ready and let's get some hydrochloric acid and aluminium in the bottles along. So guys, because we're working with hydrochloric acid, it's not something that's commonly available. So what I would suggest you do is, if you would like to do this experiment with a teacher or something along those lines, please ask them, tell them about it, and have them set everything up for you. But this is one we definitely do not recommend that you try on your own. Okay, so Chanel's going to drop in our aluminium foil. Now the thing is, with the reaction like this, metal and acid takes a bit of a while to react. So we're just going to be dropping this in.
And Simon, why are you putting the acid in first and then the foil like afterwards?
Just in case I went wrong with my calculations with the acid, we don't want it to happen too fast,
yeah,
so we're putting the foil in afterwards.
So there you
and
go.
does it matter how much foil you put in?
No,
Should I put
the
this on
limiting
now?
is the acid, yeah.
Okay, so now you pop your bottle over the balloon over the bottle top, actually. Okay, right. And then what you do is you'd leave it, or you'd give it just a bit of a shake. Just a bit of a shake to get it going. And then what you would do is then see how your hydrogen falls and inflates your balloon. Now, we've already done all of that because, like we said, it takes quite a while for this to happen. So we've got our balloon. So I'm going to ask Chanel to come and light this candle over here. And I'm going to ask the nice people in the control room to please switch off our lights.
Okay, so I'm going to swap places with you.
Yeah. I've decided to take up the role of the very brave person who's going to be responsible for lighting the balloon. I do not know why I've decided to do this, but I figured it's just a Monday, it's a fun thing to do. So we're just going to let that candle burn.
Give it away.
Guys, I'm actually quite scared right now. Okay,
hold your hand.
this one's floating, so I'm quite scared. So are you ready? Do you guys want me to do this now? You ready?
Do it,
okay, let's go. Okay, come here. Come on, balloon. This is a floater. Gee whiz. Oh! That was a good one.
Whoa, that was cool.
Lights, please.
That was really cool.
Okay, guys. If you don't know what happened with the Hindenburg, I'm sure Simon can help me quickly with the history. It was a blimp that was filled with hydrogen, which is the wrong gas to use because it is very explosive, and what happens is if you combine it with a little bit of a flame, it's going to erupt. But the great thing is, and this is why hydrogen fuel cells are great in cars, is that the only emission off of a hydrogen explosion is nothing but water, which I got a face full of when the balloon blew up. So while we recover, are you okay?
Yeah, that was very scary.
Was that exciting?
That was very exciting. I'm very happy.